Welcome to calculating age using a half-life curve. The half-life is the time taken for the radioactivity of an isotope to fall to half its original value. The age of an object is calculating by multiplying the half-life of the isotope times the number of half-lives the object has gone through. In this case, we will use carbon-14 as our isotope with a half-life of 5,730 years. Below is a graph showing the half-life curve with the percentage of carbon-14 plotted on the y-axis against the number of half-lives on the x-axis. For our first example, we have been given that object A has a 70% composition of carbon-14 remaining, and we are asked how old is object A. In order to solve this problem, we know that there is 70% of carbon-14 remaining. So as we take a look at the y-axis, we can see that that is percentage of carbon-14. So we identify 70 on the y-axis and we interpolate on the half-life curve. As we go down to the x-axis, this gives us a value of 0.6 as the number of half-lives. Using the formula that was previously mentioned for calculating age of an object, we use one half-life of our carbon-14 isotope, which is 5,730 years, and we multiply that by the number of half-lives, which we obtained through interpolation, which is 0.6. And this gives us the answer as 3,438 years. And this is the age of object A. Another point to note is that at formation, a material only contains the parent isotope. In this case, that is carbon-14. And with time, it converts to the daughter isotope, which is carbon-12. In our second example, we have been asked what is the age of object B given that it has a 20% composition of carbon-12. Since carbon-12 is the daughter isotope and at formation the object only contains parent isotope, we know that at formation that the composition of the object was 100% carbon-14. So subtracting the current composition of carbon-12 from the initial 100% would give us 80%, which is the composition of carbon-14 in object B. And since now we have the value in terms of percentage of carbon-14, we can use our half-life curve once again at the value of 80 to interpolate, and this time it gives us the value of 0.4 as the number of half-lives. And again, using the formula of age is the half-life of the isotope multiplied by the number of half-lives, we can get 5730, that is the half-life of carbon-14, multiplied by 0.4, which is the number of half-lives, and that gives us the answer as 2,292 years. And this is the age of object B.